Okay, so you've definitely seen the periodic table before, right? Probably hanging on a wall in a science classroom, looking all colorful and kind of complicated. But what if I told you it's not just some chart, it's a map? It's the key to cracking a cosmic code that explains literally everything in the universe, from the biggest, most distant stars to the very atoms that make you, well, you. So let's dive in. Take a look at this. This is the Carina Nebula, basically a giant nursery where stars are born. And here's the mind-blowing part. The ingredients that are cooking up new stars inside this nebula, they are the exact same ingredients that make up our planet, the air we breathe, and even our own bodies. The entire universe is built from the same fundamental toolkit. So, knowing we all share this cosmic toolkit, it brings up a huge question. What exactly are these fundamental ingredients? And how in the world did we go from thinking there were just 4 of them to knowing there are 118? I mean, just think about the incredible leap in our understanding here. For thousands of years, people believed that everything, you, me, a rock, a tree, was just some combination of earth, water, air, and fire. It was a simple, kind of poetic idea. But then chemistry came along and showed us a much, much richer reality. A universe built from at least 118 totally unique, fundamental substances. And each of those substances is what we call an element. What does that mean? It means it's the purest stuff you can get. You can't break gold down into anything simpler than, well, gold. These are the absolute fundamental building blocks of our entire reality. And this cosmic toolkit isn't just floating around out in space. It's right here. It's us. Now, the human body uses around 60 different elements, but get this, just 4 of them make up over 96% of our body weight: oxygen, carbon, hydrogen, and nitrogen. When you really get down to it, you are literally organized stardust. How cool is that?
But what actually makes oxygen different from carbon or from gold? To figure that out, we have to zoom in. Way in. We've got to look inside the atom, the smallest possible piece of any element, because that's where we find its true identity.
So every atom is built pretty much the same way. You've got the center, the nucleus, which is a little ball of positive protons and neutral neutrons. Then you've got these negative electrons orbiting that nucleus in layers, or shells. But here's the key to everything. The one piece of information that defines an element's identity is the number of protons it has. That's it. That number is everything. And that unique ID is called the atomic number. Hydrogen has 1 proton, so its atomic number is 1. Oxygen has 8 protons. Its atomic number is 8. This number isn't just some label. It's the element's social security number, its fingerprint. It is the single most important thing about it. It's what makes it, it. Okay, so you can imagine, once scientists started identifying all of these unique ingredients, they hit a massive challenge. How do you organize all of this? How do you take this growing list of substances and arrange them in a way that actually makes sense, in a way that might reveal some deeper, underlying pattern? Well, the answer didn't come overnight, not by a long shot. It was this huge team effort that took over 150 years. It started with simple lists. Then, scientists started noticing that some elements seemed to come in little groups of 3 with similar properties. But the really big breakthrough came in 1869 from a guy named Dmitri Mendeleev. He arranged the elements by their weight and suddenly saw a repeating, or periodic, pattern emerge. The final piece of the puzzle fell into place in 1913, when Henry Moseley figured out the real organizing principle was the atomic number.
And I just love this quote from Mendeleev, because it really captures that magic of discovery. After wrestling with this massive puzzle for so long, the final solution just came to him in a dream. It's a great reminder that science isn't just about data, it's about creative leaps and those incredible aha moments. And this is the very table he scribbled down. Now, the true genius here isn't just what he put on the table, but what he left off it. You see those question marks? Those are gaps he deliberately left for elements that hadn't even been discovered yet. He was so confident in his pattern that he could predict not only that they existed, but what their properties would be. This was absolutely revolutionary. Chemistry was no longer just about describing stuff, it was now about predicting the future. So Mendeleev's incredible insight laid the foundation for the modern table we use today. Now, let's finally decode this map of matter. At first glance, it can look a little intimidating, but reading the table is actually pretty straightforward. You've got the rows, which are called periods, but the columns, the groups, that's where the real magic happens.
elements in the same group act in very similar ways. Think of them like chemical families, and just like a family, they tend to share certain personality traits.
To see just how powerful this is, let's take a look at one of these families. This is group 1, the alkali metals. Now remember, because they all live in the same column, the table predicts that they should all behave in a pretty similar way.
So what's their shared family trait? Well, to put it mildly, they are all wildly reactive. So reactive, in fact, that you will never, ever just find a chunk of pure sodium or potassium sitting around in nature. They react instantly and violently with air and water, which is why they have to be stored under oil just to keep them from going off.
And this is what wildly reactive looks like. That explosive burst of energy is cesium, one of the alkali metals, doing its thing. It's a shared family trait. And that right there is the power of the periodic table. It doesn't just list the elements, it lets us predict exactly how they're going to behave.
So, we've gone from the ancient idea of just 4 elements to this incredibly detailed map of 118, a cosmic code that we finally managed to crack. But this leaves us with one last, fascinating question. The table, as it's designed, has room for more. So, are we done? Or are there new, heavier, and maybe even stranger elements out there just waiting for us to create them?